All right, perfect. We're going to do all that. We're going to do an environment setup with Secret.js today. My goal is to have it wrapped in the hour, but we'll see how it goes. The main thing I want you guys to learn about is working with Secret Network query permits. All right. Are you able to access the screen share? All right, here we go. Masterclass round 5. So a little bit about me. My name is Sean Rad and I do developer relations for Secret Network. The way I fell into Web3, I suppose, was I just read the Bitcoin white paper after people kept talking about the price going up for a long time. I probably heard just like 4 years of people talking about Bitcoin. And then I finally read the white paper and then I just couldn't stop thinking about it. And from there, I decided I was going to learn to code. And I, just started with JavaScript and I fell into Solidity and Ethereum first, just because I think that was the largest ecosystem. And from there, sort of my journey was that I participated in a couple of Ethereum hackathons. I did Hack NYC last summer, and then I did Hack FS following that, which was a month-long Ethereum hackathon. And just had, an incredible time learning more about blockchain development, got really excited on that track. And then I decided that I wanted to build an application with privacy features on Ethereum. And when I started just researching at the time, this is about a year ago, sort of what options were available to me, I didn't really see a way that I could create something that people would actually be able to use. Like the project I made for HackFS was a ZK DAO and it worked, but it just had it was a terrible user experience. And so that's when I started looking elsewhere to see if there was, what else was out there. And that's how I came across Secret Network. And Erdeman, who's the other DevRel person for Secret, he likes to say that I abandoned Solidity, which I don't like the way that sounds. It sounds like I wrote my final line of Solidity and then smoked a cigarette and never came back. It was more like I just discovered Secret and then I was like, okay, I guess I'm going to learn Rust now. And I came from just like, again, a JavaScript Solidity background to learning Rust. So that was my first time with like a lower level language with working with a compiler like this. And I basically just fell in love because I never felt safe with Solidity. It always felt so sketchy, especially as someone who was a newer dev. Like I was like, there's so much that can go wrong. And there is so much that goes wrong. That's why, however many tens of billions of dollars are lost each year from like dumb, like overflow errors or whatever. Whereas like with Rust, you just feel a lot more secure writing smart contracts. So once I started learning Rust, I just basically never looked back. And I started joining these weekly developer calls with Secret. From there, I found a mentor, a guy named Danny M, who's a developer in the Secret community. And I did something called the Web3 Builders Alliance, which is like another Cosmos-based bootcamp that is free. And for that, I made a capstone project built on Secret, which is this like secret business card application where you could create private business cards and use and share them with people, and no one else has access to them. So I'm going to show you a version of that app today. I created a simplified version. There's one version that exists with Secret Network viewing keys, and the version we're going to look through today exists with query permits, which is a different way to have customizable privacy on Secret. And just before we get started, I want to make sure, if you've never seen this before, in the docs, there's this setting up your environment tab. To me, this piece of the docs right here, this getting started, setting up your environment through interacting with the testnet, gives you everything you really need to get started developing on Secret. Especially, I really like this interacting with the testnet section because this explains how to use Secret.js. And I think in this tutorial, you get to just upload, instantiate, and execute a simple counter contract. So if you've never done that before, just know that this resource exists. Let me just link this in the chat real quick. Okay. So that's how you would configure your environment if you've never done that before. Just a little background on how privacy tech works for Secret. It all happens inside of this thing called a trusted execution environment. As it says, it's like a black box for data processing, and it enables nodes to verify transactions within a block without accessing the data that's inside. So every validator on Secret runs their code inside of these trusted execution environments so that no one, not even the nodes, understand the data that's actually being processed. And then that information is then encrypted and decrypted. And that's what the smart contracts are doing. So for example, with the smart contract we're going to be writing today, what it's doing is we're going to be able to create a business card that we can only share with select wallet addresses. And the nodes that are actually running this code have no idea what is actually being executed inside. It's the smart contract that has specific permissions that we set that are encrypting and decrypting this data. So let me just show you kind of something just to have a template of what we're actually going to be doing. So this is a simplified version of the dApp that I ultimately made. This one exists using only viewing keys. And I just want you to have kind of the concept in your mind of what we're going to be building, but we're doing actually a different version. This is a totally new tutorial that involves only using query permits on Secret Network. So I just want you to think of this as a framework. So, the way this would work is you'd create a business card, and from there, every single business card we create is stored at a particular index in an item storage object. So we'll talk about that in a moment. But so I'm just this card number, it basically just refers to the card index where we're storing it, which the smart contract then accesses at that specific index and wallet address. So if I do this, what it's going to do is create a card. It's going to ask my wallet to approve this transaction. And then what it does is it returns a viewing key. And the only way that I can access this card that now exists on this smart contract is if I have the proper viewing key. So if we put in the viewing key and the wallet address for the card that we want to access and the card number, and now I query this information, it should return that card. There we go. And if any of this information was incorrect, it would not be able to return this card. So there's a specific password, which is this viewing key, that is able to access this card at a particular index in this smart contract. What we're going to be doing today, this updated tutorial with query permits, is writing our contract so that basically in our card struct that we create, this which just contains this information, name, address, phone, card number. In our card struct, we're also going to add a vec, which is just like an array in Rust. And in that vec, that's where we're going to store whitelisted addresses that are allowed to access our card that we make. And so anyone who is in that array, any wallet address, they can then access the card we make only if they also have the proper query permit. And the way we're going to be implementing this today, this is not the best way to implement this. This is purely educational. I just want you guys to understand how to work with query permits. So what we'll see then is that after we create this card struct and we set up our messages, we will then only be able to query the contract if we have a query permit. And at the end of this tutorial, I'll make sure we create a super basic React app just to show you how to work with secret query permits. Because query permits, what's really interesting about them is it's all happening on the front end. It's not actually storing anything into the contract state. That's what makes them different than viewing keys. So yeah, permit is simply a dummy transaction signed by a wallet. The wallet is able to use this signature as proof that the transactor is who they say they are. And any wallet capable of using Tendermint is able to carry out this process. So yeah, again, instead of storing a password or a viewing key in the contract state, the user signs a piece of data with their private keys. That's the private keys associated with your wallet address. So every wallet has a public and a private key associated with it, right? And then it sends this data and the signature to the contract along with the query. The contract then validates the signature against the data and returns the answer if the signature is validated. This way, users don't have to send a transaction before they can access their data. And if you want to see more information about this, I've linked this in this talk, and I will make sure to post this into the HackSecret GitHub. This is more information on query permits and specifically kind of how their data structure is designed. This is pretty confusing, I would say. It took me quite a while to get to this simplified version of where we are now. So this is why I'm really excited to share this with you guys, because I'm hoping, by the end of this, I will also push this GitHub repo that we make so that hopefully you'll just have an understanding of how to use query permits and a very clear example of how to actually, use them in your dApps. So this is all that we're going to be implementing all this today in the code that we're looking at. I think, yeah, that's it. So let's get started. Oh, and this is the repo that we're going to push to by the end of this. So I'll just link this here for you guys. All right. So now you should all be seeing my VS code. Let's see what we got here. So I'm just going to do this tutorial as if we're all pretty brand new to writing smart contracts in Rust and using Cosm Wasm. It's a lot different from Solidity. Or honestly, on a bird's eye view level, it's very similar. But in terms of how you actually implement things like an instantiation message, for example, it's a little different. So the best way to think about this structurally is we have three main files in our smart contract. We have our state, which is just the storage of the contract. So we're going to be storing this card, right, that we create. And also we're going to make sure that card is mapped to an index so that then when we access that card, the way to think about this and the reasoning behind this is just, it's the idea that let's say I want to make 100 cards, right? And each card I want to provide different access to. Then for each card I make, I put it at a different index, and then users can access specific cards at specific indexes that I permission them to be able to do so. So state is our storage. Okay. MSG message. This is all of the messages that the contract is actually executing. So all we have is an instantiation message, an execute message, this is like the create card and burn card functionality. So we're able to make a card and we're able to delete that card. And then a query message, which is querying the cards that exist. And that's where we're going to use this permit. And again, something else I should mention up top is that permits are specific to Secret Network, and we use them through the Secret Network toolkit, which is a specific crate we import into our smart contract. And then we get all this additional functionality. It only exists on Secret Network. So we'll make sure we look at how to do that. And then our contract is where all of the logic of our code actually happens. I have most of this written out. I have our create card function written out. I have our burn card function written out. What I really wanted to just do with everyone today, because I'm trying to keep this under an hour or about at an hour, is to write this query card function with you so you understand how to use the Secret Network toolkit to use query permits. All right. So I always like to start with the message file because that's what the contract is actually doing. I think it's like easier conceptually to think about your smart contract this way. So the instantiation message is just if there's any information the contract needs upon instantiation. It's often common in this message to include like the user, the wallet address that is the owner of this contract. We're not going to do that today, but just know that information. Another thing is that like if you use the Secret Network toolkit to have like the random number generator, that's something in the toolkit you can use. If you were to use the random number generator, it needs to have entropy to pull from. And so when you instantiate your contract, you would also instantiate it with like a string that is just the entropy that the random number generator uses. But again, we're just going to have an empty instantiation message today. So execute message, all we're doing is creating a card and burning a card. I already have this written out, nothing to change here. I think, all we need to write on this page is this query message. And another thing to note is that when we query the smart contract, this is our enum, what it returns is a response. And we have to define that response in our message file. So what we want to return upon a successful query is this struct I created, which is just a card response. And what it returns is the card. So all this is saying is that upon a successful query, we return a card. And to get our card, we need to be able to access it for the specific wallet that we're trying to access, right? So if I make a card and you want to be able to access my card, then we need to make sure we have that wallet address information. So I'm just going to add in a wallet. Something great about Rust is it's very handy in terms of telling you like what you need to import if you don't currently have it imported in the smart contract. So adder, ADDR, this is just a wallet address, just like a string that is your wallet address. We need a permit. Oh, and I also have GitHub Copilot chugging along with us. So it's going to probably know what to do because it's probably seen me type this before. The future is now. And an index. Beautiful. And this is all we need in our query message is the wallet that we're accessing the index of the card that we're accessing at, and then the permit that validates that says this query is okay to happen. It looks like and if I save this, right, I just Command S, it probably should throw some errors. Good. So it's because we don't have adder or permit currently imported. So let's just view the problem. And then usually when you do that, it says, would you like to fix this? There we go, quick fix. So I'm going to import secret toolkit permit, and I'm going to import adder. And now this should be compiling. No more errors, hopefully. Cool. So notice that what was just added here just now is use CosmWasm STD adder and use secret toolkit permit. If you're like a front end dev, for example, and you know, like your, what is it called? Your JSON file. Is that what it's called? I'm blanking right now. The file where you have all of your imports, right? In Rust, that's the cargo.toml file. So this is where we're actually importing these things like our secret toolkit that has specific packages like the permit package. And same with CosmWasm STD, which is where that adder is being pulled from. So you want to make sure that in order to use these dependencies, you have them imported in your cargo.toml file, and then you will be able to have access to them here. So we now have our message file written out. Let me just check messages really quick. Can you also talk about Polar eventually? So Lander, great question. There's actually a talk with the Polar devs next week, I believe. So just check back to the Secret Network schedule for the hackathon. And I think they'll be showing how to use that next week. Today, we're just going to be using basic Secret.js, which I think is really good just to have that understanding. All right, let's define our state object real quick. So this is also really simple. Again, all that we need is this card struct, right? And so in our struct, you guys in the chat, just let me know something. What do you want included in our business card in terms of, oh my God, look at ChatGPT just going off. What sorts of things would you want in our business card for today? Feel free to just write something in the chat. Like this variable is just like name, phone number, address. Okay. I saw email. Okay, great. So I saw email. So I'm just going to jump back into the code. So let's just do a name, a email, and our whitelist variable. So this variable here, a whitelist, this is going to be where we write in to our contract the wallet addresses that are allowed to have access to this specific card. Again, I wouldn't do it like this if I were like making this for production. This is just for you to understand how to use query permits. So don't take this as like, the only way to do this. This is just an example. All right. I think with that, I already created this user cards key map. So do we need anything else here? We have this. I don't think so. We actually don't need this item. So yeah, this key map just makes it so that each card is associated with an index. All right, let's just jump into the contract. And I think I have yes. Oh,
Can it accept other data types aside from strings?
Yes. Yeah. Whatever. The sky's the limit. So anything else you wanted to put in there, you'd be good to go. Like this is actually a vector containing a string as a data type, for example. So this is an array of strings. And so for this example, all we're going to be doing is just like adding into this vector wallet addresses, which are strings, which are allowed to access our card only if they also have this permit, which is what we're going to be learning how to do today. Great question. All right. So let's jump into our contract. The other thing is I'm just trying to save time for us to also upload, instantiate, execute, and then query this. So I think I have everything written here. Whenever it underlines this, it's because it's an unused import currently, but it's unused because we're going to implement it in our query function. But Rust is great about letting you know if you have any unused variables or if something you have is currently throwing errors, it will just scream at you until you fix it. So here's our instantiation message. We only have 3 entry points in our contract, right? We have the instantiate message, we have the execute message, and we have our query message. And because our message file in our instantiation message in msg.rs is empty, so too is our instantiation message here. If we needed anything in here, like if we were configuring an owner of the smart contract, that information would go in our MSG file and then also here in our entry point instantiation message. So in Rust, it's very common to use match statements in your execute message for the kinds of execute messages that your contract can actually do. So again, these messages, all they're doing is just coordinating with the messages we define in our message file. So execute message, we have 2 options. We have create and we have burn. Now you go back to our contract, execute message, we have create and we have burn. And then for this match statement, we define a function for each of these statements that is then accessed depending upon which function the user calls. So create card, we have create card and burn card. Again, I've already written these out, but I'll just kind of go over this really quickly. So what this is actually accessing, the parameters that are passed into this function, I highly recommend after this, just cloning down the repo and maybe digging into this more, because here, for example, if you go into what is deps, that's the dependencies that the contract's actually accessing. So these are all of the external dependencies of the contract, storage, query API. And then if you go into message info, for example, this tells us some more information about what this actually is. This is all COSM WASM framework, by the way. That's what we're working with. So things that we have access to in this message info are if any funds are being sent and also who the sender is. And so we can then use this parameter in our function. So for example, in our create card, all that we're doing is returning this response if this is successful. And what we're doing is just saying for our user cards variable, which is the key map we defined in state, right? So we define this variable user cards, which is a key map that associates a card with a U8. We then import user cards into our contract file. So you'll see up here, if we go up to state, use create state, card, user cards, we're importing those variables. And then in create card, what we say is for our user cards key map that we imported from state, we add suffix. And this is just a method specific to Secret Network. So again, if we were to click on this and go into this, we'd learn more about what this function is actually doing in Rust and understand that this is specific to the Secret Network toolkit. All that this actually does, though, is it takes the info sender as bytes and associates it with this key map. So remember what I just said about how in this message info parameter, we have access to who the wallet address is that is actually calling this function. Because if we look at this again, we see we know who the sender is. So we have access to this adder variable. So all that this is doing then is taking this user cards key map, and this add suffix method is accessing this info.sender, so the person who's calling this function, and then just associating that wallet address as bytes with this card that's being added. And then it inserts that card into storage of the smart contract at a specific index. That's the key that we're passing. Okay. So all that to say, all this means is that now when we call this function, what the smart contract knows is who the wallet address is that inserted this card at a specific index. That way, when someone goes to query the card, all they have to do is know, who the wallet address of who created the card and the index so they can then access that information. This way that like anyone can access this smart contract that we're developing and store their information on it. And nobody else has access to anyone else's variables unless they've customized that privacy, which is pretty cool. Pretty awesome. I don't know. To me, it's like magic. The idea that there's this thing we're all operating with and using, but we only have limited access based on the customizable privacy we define in our smart contract. 1 second, I'm just going to take a sip of coffee. And then we have this burn card function, which is basically doing the same thing. One other thing to note with this is that we have this get method that is specific to Secret Network Toolkit. So it's just saying if the user exists, right? So if this card exists, so it accesses the user wallet again. So if this person has stored a card, then we retrieve the card at that index using this get method, which is specific. And so then if this user exists, we use this match statement that says, then remove, that's again specific to Secret Network, remove the card at that index. Otherwise, do nothing. All right. Now, meat of this tutorial is defining our query message and working with query permits. So this is something I learned recently from another developer when I was doing a workshop last month. If you ever have code that is incomplete in your contract, you can use this to do, and it will make it so that your contract doesn't throw errors at you, which is kind of nice. So like if I were to remove this and then save, then all of a sudden our contract is throwing these errors. Whereas when you put to do, it says, hey, this is going to happen, but I'm not going to throw errors at you. And you can live in peace for a moment. Okay. Let me just check the chat real quick. Awesome. We're still rocking. Okay. So in our query card function, and something you'll start to notice is like how similar this query message structure is to our execute message structure. You see, we're just passing these match statements. It's the exact same thing. If you go back to our message file, but we only have the one message this time instead of two. We just have the one query we're trying to do, which is to retrieve our card at a specific user wallet address and index. And it can only happen if they have this query permit. So we got to make sure we pass these parameters, right? So if we go back to our contract, we have that all set up here already in our query message. We have our wallet, our permit, our index. And again, all that information is passed here into our query card function. Okay. So let's do this. Let's set this up. So the first thing we're going to do, sometimes ChatGPT doesn't know what it's talking about. First thing we're going to do is access our contract address. And we can do this by accessing the environment variable. So like this. Cool. So all this is doing, again, if we go into this parameter, now we're accessing this environment parameter. And we look at this. You have access to the block info, the transaction, and also the contract info, which is the address and the code hash of the contract. So what this means effectively is just that like in our query function, we can access this variable of the specific contract address. So that's what we're doing here with env.contract.address. And now what we're going to do is create this query permit, right? So let me show you. So what we need to do is create a viewer, and the viewer is just the person who is trying to query the contract. That's all that it is. So see if ChatGPT does this right. It does not. Um, and then this is where we're accessing the contract address. We have to access it as a string, I believe. Okay. If you're like all of a sudden like WTF is happening, that's good. That's why we're doing this. So fret not. I think this should be right. Okay. So this validate method, this is specific to the secret toolkit, and this is specific to query permits. So if we go into this now, this is what is all actually happening behind the scenes with validating our query permit. Okay. So this probably looks pretty scary, but it's actually really simple on the contract level once you understand what we're doing. All that it's doing though is making sure that the permit is validated. Um, and if we go back to, where did I have that? This information, right? Let me just link this in the chat for you. This is the data structure that we're working with. And all this information is in here, I think. Yeah. So I just want to make sure you have all this information. This is what we're doing right now is like a practical application of what this document teaches you. Yeah. And again, so this data structure for query permits was chosen to accommodate Kepler and Secret D, which already know how to sign and don't require extra code and support. Okay. Let's jump back in. So all this validate method is taking is it's accessing our depths parameter. It needs a storage prefix, which we define in state. So all this is literally, you can make it whatever you want. This is the string revoked permits. We have the permit that we're actually passing into this method. And then we have the contract address as a string. That's all the validate method needs is these four objects, is a string for the storage prefix, the permit itself, the dependencies, and the contract address. So then I think this is actually right. Good job, ChatGPT. So this is saying if the card exists with this specific wallet address, then we retrieve the card at that index, similar to what we looked at earlier. And now here's the magic of like actually using the query permit to say you can only access this card if you have the correct query permit, right? So we say create a match statement. I think we actually want it like this, but this is close. Okay, so we say if card.whitelist.contains our viewer, return that card. And so remember again in message, we created that card response struct. All that that's doing is making it so that we can return that card. Else, okay. And if there's none, nice. Okay. And I think maybe we just need another All right. So does this make sense to everyone who's watching what we just did with this function? I'm going to check the chat real quick for any questions. Take a sip of coffee. If this makes sense, we can jump into the front end. How's everyone feeling? See that two people are typing, so I'm giving it a second. Yes, let's go. Okay, cool. So conceptually, we're all on the same wavelength. Love that. And Poopy, the being new to Rust, I was in the exact same boat with you, like as recently as like, I don't know, 6 months ago. So it all just gets easier the more you work with it. Um, but I'm glad that at least conceptually this is making sense. So yeah, so all we're doing, the most important thing to note is just that in this query function, rather than having a viewing key like I did in the previous iteration of the step, instead now we say we have to have a query permit. And if we have that query permit, um, and here's another important thing to note. So this viewer, see how it says it's a string? All this actually is just like the wallet address that is calling the query function. Okay. But it's not saving that into the contract state. It's just accessing it through through Kepler. And so then, because in our whitelist struct, we create this whitelist, this vec of addresses. If that vec of addresses contains this viewer string, contains this wallet address, then they're able to access a card. That's all that this is doing on a really simple level. Cool. So let's now do this. Let's create a query permit on the front end. The first thing I'm going to do is compile this contract. So let's do that. So to compile a contract in Rust, go to your make file. And then from here, if these have already been defined, so we want to build an optimized version of this. So we're going to say build mainnet. And this is just generating the WASM file from our contract. Okay. That's all this is doing. So I got a CD into my contract folder. And then I say make build mainnet. And all that that's doing is this make file is just calling this script right here, which is generating the WASM file of our smart contract. So call that. Hopefully this compiles successfully. We'll see. And then in the meantime, actually, we're going to CD into this node folder I just created. And package.json. That's what I was trying to say when I was saying the TOML file. Okay. And then in our package.json, we're going to install secret.js so that we can then upload, instantiate, and execute our smart contract. Awesome. And then in our package.json file, something else we need to do is just change the type of this to module. And I'm not sure, maybe you guys are more, know more about why is this saying this is the important part. ChatGPT is so funny sometimes. I don't actually know why this is. I just know that this is what you got to do to be able to call the functions that we're going to be calling. If somebody in the chat knows why I need that, I would love to learn right now. So let me just make sure that that goes through. All right, so we have secret.js installed. So now let's create the file we're actually going to be executing. And let's see if our contract successfully. Okay, beautiful. So it successfully compiled our contract. And when it does, then it just generates this right here, this contract.wasm file. And the optimized version is this .gz. So that's what we're actually going to be uploading to the secret network blockchain. Okay. I'm just going to paste in template code for this so we don't take up too much time. And then just walk you through what I actually did. Give me 1 second here. Okay. So first things first, we import secret.js, right? So that's all this is doing, is importing secret network client. And so let's just see an example of that really quickly, actually, so you understand what's going on. So this is just saying that we're accessing the blockchain. And specifically, we're accessing the test net. So if we were to change this URL right here and this chain ID to secret network's mainnet, then we would be, that's the chain that we would be accessing right now. But right now we're accessing the test net. So literally like what we're doing right now, you could do the exact same thing for mainnet. And the only difference would be how you set up your secret network client. So let's just make sure that this is going through properly. And we'll just say, node index.js, and it should console log. Beautiful. So there we go. This is just saying that, hey, I'm accessing the client. This is my wallet address that's doing this. And so this is the seed phrase of my wallet. It's a test wallet. Make sure whenever you're, doing stuff like this, you have a wallet that is not your main wallet. You want to just have a wallet you specifically use for testing with dApps with no actual real finances on it. Okay, so let's upload. And this wallet parameter right here, this just makes it so that then in our secret client, we have access to our wallet. So there's our wallet, and then there's also our wallet address. So for example, yeah, I think that makes sense. So first things first, we're going to upload our contract. All of this information right here in terms of like boilerplate code for uploading, instantiating, executing, and querying, this all lives on the secret.js docs. So let me just show you that real quick. Okay. So like if you were to control find in this and go to like upload, for example, this is information about how to do exactly what we're doing right now. I've just kind of streamlined it for the specific dApp we're doing. But I just want you to make sure you have access to this resource. It's a great resource. I'm going to post it in the chat right now. All right. So we're going to upload this contract and it's going to return a code ID and a code hash. We have to make sure we're actually accessing the contract. That's what this file is, contract wasm. So the wasm that we generated over here, contract wasm.gz, we're just linking to that. And this is what's actually being uploaded to the blockchain, to the testnet with this upload contract function. So let's call that. Let's see if that's successful. Awesome. So upon successful upload, it will return a code ID and a contract code hash. Let's just store those as variables. (20902), and then we have our contract code hash, which is a string. All right. And with this information now, this is what we use to actually instantiate the smart contract. So I'm going to comment out this upload script. So this contract now exists on the secret testnet. That's what just happened. Now we have to instantiate it to actually be able to use it with our information. Let's do that. Okay. So we actually don't have an init message. Or we do, I guess, but it's empty because we're not using entropy in this script. So I think I got to go like this. And all this is doing is just saying we're instantiating it with the code ID, my wallet address, the code hash, my instantiation message, and a label. And then if this is successful, it's going to return to us a contract address. So let's try that. Oh, wow. Did anybody else just get a ton of dopamine? This is our contract. Okay. So now we should be able to actually execute this smart contract that we just wrote together. Let's try that out. Let's keep this const just to keep things uniform. So we're going to create a card. Do this. So all of this message information in our create card, it's just pairing with what we define in our message.rs file, right? Or I mean, in our state object. So the card has a name, an email, and a whitelist. So let's try that. So we go back to our index.js. We call create, right? That's what it's when we call create, what that's doing is calling this function right here, and it creates a card at a specific index. So we have to enter that index information and that card information. So we create our card. Let's call it Boopy. Address is secret lane. We don't actually have all this information now, though. We have an email. So boopy123 at yahoo.com. I don't know. I just have a feeling Boopy's a Yahoo guy. And then we have this whitelist of people we want to actually be able to access this card. If anyone has a secret testnet wallet address that they'd like to paste into the chat, I can also add you to this just for funsies. Otherwise, I'm just going to use 2 of my testnet addresses. And then we're going to create this card at index 0. Okay. Let's just double check. So name, email, whitelist. Let's make sure that that's what we define in our state file. Name, email, whitelist. And again, it's a vector, so it's just an array of strings. So this is an array of strings, and it's just 2 testnet wallet addresses that I have. Okay, let's try this. I'm going to call create card, and it should just return a transaction log of this if it's successful. Cool. So this is all the information about this specific transaction we just called. This is all the information about just creating this card, right? Okay. So this is the cool new part about how to use query permits on the front end. We just learned how to use them with the validate method using secret toolkit in our contract. Now, this is how to actually use it on the front end. So for funsies, I'm just going to create a React app. What is the code for that? npx create React app, right? I'm Googling. Bear with me. Okay. So we're going to generate our React app right now. And all that we're going to do right now is just make it so that we have a button on the front end where someone can generate a query permit. And then we can query, we're going to call the query function with a button. And the query will only be successful if they have the proper query permit in order to access this card. That's the next and final step of this tutorial. We're very close to the end, probably like 5 more minutes. Why do we need to hard code wallet keys and contract information? So the only reason we need to hard code the VEC, like this whitelist VEC, I'm responding to Boopy's comment right now. Why do we need to hard code wallet keys and contract information on index.js? We only need to hard code this whitelist because that's the way I defined it in state. I would not do this for like a mainnet application. As I said earlier, this is just for this tutorial purposes to show you how to use query permits. If you're asking like why we need to hard code the actual variables into this, like contract code hash and contract address, that's just so that I can then, when I go to like actually execute the contract, right? I'm just making it so that I can have easier access to that variable. Yeah, line 5. Oh, you mean right here? Why you need your wallet? So great question. So Boopy's asking why on line 4 do we need to have this wallet? So this is the wallet that is actually calling all of this information. So like this makes it so that all these transactions we're doing, they're specific to my wallet address. That's who instantiates the smart contract. That's who's executing the smart contract. That's who's creating the cards. This is accessing my wallet. You don't need to do it like another way. The way you would do this if you were to push to mainnet, for example, is like have a .env file where you keep your mnemonic in that, and then you just import that .env config thing right here instead of actually having this. Hope that makes sense. All right. So what are we rocking with now? All right, we got our React app. Let's just get rid of all this boilerplate stuff that we don't need. I think we can delete all that, right? Delete. We don't need this. We don't need this. We don't need the logo. npm run start, right? Because I'm not in the query folder. Please let me say yes. Run on a different port. There you go. Okay. We got a React app. We're cooking. So what we're going to do is, remember earlier when we were looking at this information and I said we were going to just have a practical example of how to use this? That's what we're going to do right now. Give me 1 second. I'm also going to copy this in so we have, for time's sake. And I'm going to make sure I push this to my GitHub so that you all have access to this afterwards. All right, let's do this. All right. So remember what we were just doing in Node, or in our index.js file where we had to import secret network, client, and wallet. Same thing goes for React. My goal with this is just for you to have an understanding of what this actually looks like working with the front end framework. So we're doing this in React. What we just did with importing or with uploading and executing, now we're going to use this to query, but with React. What we need to update here is our contract address, right? We want to make sure we're working with the correct contract address and code hash. Okay. Allowed tokens. This is a parameter specific to query permits as well as permit name. So allowed tokens, all that actually is the contract address. So we're just saying that we're giving permission to the wallet address to access this contract address. That's all we're doing. Okay. Oh, can't resolve secret.js. So it's saying that because we got to install secret.js and React. Let me just check the chat real quick. Great. Still looking good. Okay. So here's what we're doing. What we're returning on the front end is 2 buttons. Our create viewing permit button and our query card button. If we look at our query card function, this is using secret.js to query the contract at our contract's contract address and code hash. And we're querying specifically this wallet, which this is the wallet that created the card at index 0, which is the index we specified when we created the card. And we're saying that in order for this wallet to be able to query this card struct, they also need to have this query permit. Okay. And so in the query permit, we have the permit name and the allowed tokens, which is the contract address, and the signature object, which is generated when we create our permit. Okay. So I wasted a ton of time on this last night, by the way, trying to figure this out. This signature is actually an object. It's not just, I thought it was just your public address. It's something specific to Kepler though. So which is why I ended up doing this in React. And we can actually console.log our signature if you want to see what it looks like. But what we're doing though is just in React, we're saving the state of the signature once it's generated. So this is the create viewing permit function. It's accessing our Kepler wallet to generate this signature based on your address. And look, so most of this is just placeholders specific to query permits, like chain ID, account number, sequence, fee, gas. All that we're actually changing here is saying what permissions we're allowing, what the allowed tokens are. And in our case, it's the smart contract that we just created. And then the name of the permit, right? So because this permit name needs to be the same when we then go to query, where it has to have the same permit name and the same allowed tokens. And then also we have to have our signature create, right? Does all that make sense? Now let's actually see this in action. So what this is going to do, right? If we did this successfully, fingers crossed, what's going to happen is when we query the card with the query permit, it's going to console.log the card that we created, Boopy's card, right? With his email, with his Yahoo email. So let's try that out. And right now this query card button is hard coded, right? To just have the wallet address that we're trying to access, but like, in a more robust front and you can make it so that you could put in any wallet or index, example, etc. So we should not be able to query this card right now, right? Because we don't have a permit. So hopefully this fails because otherwise we did not write our contract correctly. Okay, great. So it returns an error, parsing into type secret business card demo. That's what this is called. It says the query message is invalid. So now let's create a permit. And so again, when you create a permit, it's all happening on the front end, right? That's like why this is so efficient. It's just creating a permit with your signature, which then you're able to use for queries. So I'm going to create my permit. And this is just using, your public wallet, your wallet address, right? It's not actually saving any state to the smart contract. So we approve it with Kepler. This is that signature object that I was talking about, where I wasted a ton of time last night because I was like, I didn't realize this was an object. I was just passing this signature string, but you have to actually pass the object. So now when we query the card, we should be able to do this because we now have a permit specific to that card. And there we go. Card returned. Boopy123@yahoo.com is the email, name Boopy. And we have that again. This is like what I would not do for a main application is actually include the whitelist and the struct itself. But this is just an example for you to see how query permits work. So that is our tutorial for today for understanding how to use query permits on Secret Network. I hope you guys learned something. I know there's a ton of information that we just digested. And while everyone's here, let me just push this to GitHub really quickly so we have the updated information. Are there any questions or thoughts in the chat before we conclude this session? Yeah, you can use your mics. This is just a shy group.
Oh, hi. Can you hear me?
Hello. Yeah, sounds great.
Yes. I was just saying, I don't know in the site in the Squid network whether they do like cover the basics on Node and React because I'm not quite like I have worked on some project, but not too familiar with the workings of it. Yeah.
You mean, I also didn't know that at first. Hopefully, were you here for the entire tutorial? Did you watch what I was doing?
No, I was having I struggled to actually even get to this like Discord server because on the site on the end site it didn't have like a proper, what do you call it? Like when you click on the link to go into the meeting, it doesn't take you to this. It just takes you to like a normal Discord, like it's my Discord homepage. It
Okay,
didn't
that's
take me
like
to
good to
this
know.
like server here.
Okay, that's
So,
good feedback. I'll make sure we have that link properly. So I recorded this entire session, so I will post this video on YouTube, hopefully today or tomorrow. And then everything for HackSecret is linked in the HackSecret repo.
Okay.
First of all, here's the repo we just worked to get on together. Make sure you guys have this. And then in HackSecret, all of the videos are being posted here. So you can view all the recorded workshops. And secondarily, they're also linked here. So I'm going to link this here, hopefully tomorrow, maybe Monday at the latest.
Okay.
What? Yeah. So you'll see how I use Secret.js to upload and instantiate. And also, yeah, something we talked about at the beginning of this call. If you scroll up in the chat, you'll see this interacting with.
Yeah, because I saw the prior instructions which didn't follow. I think I don't have Rust. I think was one program they mentioned, which I didn't.
Oh yeah.
Yeah.
Yeah, you're definitely gonna want to install Rust. So just go to the secret docs, to the getting started docs, which I linked up top in this chat, and that'll teach you how to get your environment configured properly.
Okay. Okay, thank you.
You should have everything you need to go. And DM me if you have any questions or get stuck at any point.
Okay, thank you.
You're welcome.
And then yeah, can you I think I heard you speak about a hackathon. What's the hackathon on?
Oh yeah, so this hackathon is happening right now. It just launched this week. This is HackSecret, and it's going on for a month. So if you go to the HackSecret channel, which I think we're in right now, you'll see people are still looking for teams. So you should definitely join. There's tons of cool projects being worked on. And yeah, you'll just learn a ton about how to develop with Rust and on Secret Network if you build something this month. To me, the best possible way to learn is to build something, just to get started. That's how I started on Ethereum, was just doing hackathons, jumping into the code. And I was always really intimidated at first because I was surrounded by all these great developers and I felt like I didn't know anything. But that's how you just like 10x your development speed, I think, is just being around people who know a lot more than you, not being afraid to ask questions. There's no dumb questions. Yeah, and you just continue to grow that way.
Okay, so I should just go to looking team. I should go to hashtag looking for.
Yeah, and you can officially register here. Let me send you the schedule. So use this link in the chat.
Please send it in the chat, or I don't know.
Yep.
Yeah. Okay. Okay. I'm seeing it now.
Cool.
Okay. I've opened the tab. Okay.
Yep. And you'll see all the information there to register and the schedule and everything else.
Okay. Okay. Thank you. Thanks so much. Okay. So that means that I'm a bit like far behind, because I can see that it like started on the 17th.
We just started, so you're not even far behind. Like, yeah, if you get started right now, you're totally good. Yeah. Yep. All right. Thank you so much, everybody, for watching. I hope you learned something about how to use query permits today on Secret Network. Feel free to DM me if you have any questions. Also, follow me on Twitter. I'm just starting to become a poster instead of a lurker. So yeah, give me a follow if you guys are on Twitter. I'm going to link my handle in here. Yeah. And then stay tuned later tonight. We have a Secret University developer workshop with DDD, which should also be great. And another one on Monday. So just putting out a ton of content and hoping you guys just keep learning. Yeah. There's no better way. I fell into Secret knowing almost nothing and then just stuck around and just, yeah, you just keep learning the more you're just around this stuff. So excited to be here building with you guys and hope to see you soon. Thanks, everybody.